Hello guys and welcome to another video. My name is Stefan Persson, also known as Imphenzia. We're gonna create a little simple physics-based platformer and create a bunch of these visual scripts that will help you understand how to move the player, how to make it jump, how to make it not fall through the ground, how to make it face in the right direction, and how to make it animate as it runs and jumps. Make sure you stick around to the end of the video as well, because we're gonna take these visual graphs and turn them into C# scripts so you can see how it compares. Should you learn visual scripting with Bolt, or should you learn C# scripting, or should you learn both? You're going to be able to make a decision after watching this video. I'm also going to show you what not to do as well, because there's some things that you don't want to do. In episode 41 of my 10-minute modeling challenge, I modeled the level assets that you see in this video, and I also created the base project in Unity and imported those assets. In episode 42 of the 10-minute modeling challenge, I modeled a character, and in the bonus material I animated him, and we also turned him into a ragdoll in Unity. And in episode 43 of the 10-minute modeling challenge, we modeled the environment assets, and we also implemented those with some post-processing in Unity. Okay, so the first thing we need to do is to install Bolt, and Bolt is in a little bit of a transitioning process because Unity bought Bolt. It used to be an asset in the asset store. And still you can download it from the asset store, and the asset store has actually moved to the web. They moved it out of the editor. It's a bit surprising because it was always so neatly integrated into the engine. And when you download it, you actually have to go to the package manager and install it that way. You have to go to My Assets, and from there you can install it. There's another package called Bolt as well, so don't confuse it with that one. It's a network one. Just make sure you pick this one, the visual scripting one. Go to Tools and then Install Bolt, and then click on Import. If you don't know which one it is, it's probably going to be .NET 4X. Otherwise, you might have to check it, but I usually just click on the default. Then click on Import and let it run through the course. And then we're presented with a little setup wizard. So just click on Next on that one, and then you can pick if you want human naming or programmer naming. I'd probably usually go for programmer, but for this purpose, I'll put human naming, because if you don't know programming, maybe it's a little bit easier to understand those. For the assembly options, I just click Next, and also for the icons, I just accept the default and I click to generate. We can close the wizard now, and then let's get started with making the game here. So first we're going to make the hero controller, which is a flow macro, and we're going to create the first macro now. I created a folder just called Bolt, and then I right click and then I create a new flow macro. And I name it Hero Controller. This is going to be the main controller for our character. You can go to the little Flow Graph tab, and you have to go to Window and enable it if you don't have it. And then you can right click, and then you have to start typing in things that you want to search for. You could also browse them. It might be a little bit overwhelming, so it might be worth Googling a little bit to see what you need. The first thing we're going to need for this one is the input get axis, and we're going to type the axis name of horizontal. We can go to Edit and Project Settings, and then go to the Input Manager tab, and then expand the axis. And then you can see that we've got one here named horizontal, and it's taken left and right arrows and also A and D keys as input. You work in the flow graphs here by linking these together. So I right click to create another unit, and this time we're going to create a vector 3. And we want to have the XYZ input here. And then first you connect the horizontal input there to the x-axis, because we want the character to move left and right. And then we right click and search for another little component here in the graph. And we want to pick the rigid body set velocity. And then we have to drag from the vector 3 output until the vector 3 input on the set rigid body velocity. This needs to run in the physics loop, the fixed update. So I right click and add fixed update, and then I link the little green execute arrow to make sure that that one runs as well. Otherwise, it won't really execute that part of the visual graph. Then I have to click on my hero in my hierarchy, and then click on Add Component, and then I add this flow machine. And then we click and drag the hero controller onto the macro itself. I just adjust the columns a little bit so we can see better. Then we press play to see what happens, and we get an error down here, and it's because the object doesn't have a rigid body yet. So just press play again to stop, and then we add a component and search for rigid body, which is the physics object. And then we're going to leave most things default, but we want to switch on interpolation so it runs a little bit smoother. When I press play now, it sinks slowly through the ground, and there are a few reasons for that. First of all, I'll disable the flow machine, because it's actually changing a few values that we don't really want yet. And then I have to add a collider. I pick a box collider now because usually you might be using a capsule collider, but I have a tendency to slide the player off. Tweak the values so I get a pretty good fit to the player, and then we press play to make sure that it drops down to the ground. Then we enable the flow machine again. If we select the hero in the hierarchy, we can see the flow chart running, or the flow graph. And when we press left and right, we can also see that the player is tumbling over, so we have to fix a few things. So we press play again to stop it. Go back into the rigid body and then freeze the position on all axes. This will prevent it from rolling over. If we look in the scene view, you can see that we don't really want the character to go at all in the Z direction, the blue one. We only want it to go up and down and left and right. So we can freeze that position as well to prevent it from accidentally going into the scene or towards the camera. Now we see that it still slowly edges itself down. And we have to fix that one as well. And now it's the flow machine that we need to tweak a little bit because we did a little error there. If I go back into the flowchart, we can see that we're actually setting the Y component to 0 all the time. We can right click to the left there and then search for get velocity. And we get the rigid body velocity in particular. And then we also get the Y component from that one. And we have to link these together. So we link the two vector 3 connectors together from the input to the output, and then we drag the output onto the Y component, and this way we get the velocity already from the rigid body that it has up and down, and then we make sure it sets that one back as well. So now it might be moving a little bit slow sideways, but at least the falling down works pretty good now. To fix the movement speed, we can make a little bit room there, right click and add another unit, and this time around we'll search for float. And then we'll just get a float literal there so we can type in a value. And this is going to be a multiplier. Let's type in the value 8 to multiply it by 8. And then we have to right click, add unit and search for multiply. And then we just pick a little multiply component. Then we have to make a little bit more room and then link these together. So we take the horizontal value and put it into A, multiply it on the B component there, and then link that one up to the x-axis. And now you can see when we press left and right, the character is much faster. It sticks a little bit on the walls, but we can fix that as well. During play, we can see that the player has a little skip as it goes from one tile to the other. So let's press play again and have a little look. And as we go left and right, it does a little leap across those edges. And it's quite common for these box colliders to catch a little bit. And we add a sphere collider on the feet here, and then put a really small radius and push it up just a little tiny bit. So this one can act as a little roller, like a wheel nearly, to help it skip across. And the reason why we don't have a capsule collider only is because if you only had that, then it's very common that you start sliding off the edges of the tiles, and that's a pain too. Okay, I'm going to show you multiple things to do this, but what I found is that it's really important to keep your components or your visual graphs very tidy. And you spend a lot of time just fiddling a little bit, moving them up and down and try to position them so they don't collide. But what I like to do is to keep the graphs really small, so I start breaking out stuff into separate so-called super units. I'm going to show you many ways to do it, but now I just mark a few components and I copy the selection, and then I right click in the project folder there on the bolt, and then I do create bolt and a new flow macro. So I get a blank macro there, and let's name that one just move, because this is going to be the move logic. So I press Ctrl V to paste it in. And then you can put a title to it in the little graph inspector, and if you don't see that one, you can enable it in window as well. For value inputs, I'll type in horizontal because we need that input value, and it's going to be a float value. And then we also need to add another value input called speed multiplier. And then we select that one to be a float as well. Now I can right click in the graph and select add unit, and then we'll search for input and make sure we pick this nesting one. And when we click on that one, those two ones that we just created, those inputs can be accessed. So we drag horizontal to the A and speed multiplier to B. So now we've linked together from the other flow graph from our hero controller. If we go back here now, we can delete these components that we just copied. And then I have to right click, add unit, and then we can browse our way to nesting super unit. And that's going to access our thing. We can change that one to a macro. And then we can just drag the one into the macro there that we've created into the graph inspector. And that exposes those two inputs that we created. So now we link the get axis from the input to horizontal, and then we get the float there to the speed multiplier. And I'm going to show you many ways to do this. There's actually nicer ways to do it than copying and pasting, but I just want to show you that there's many ways that you can do it. Okay, so we press play and see what happens. And if you have the hero in the R case selected, we can see these little node graphs flowing quite nicely, so we'll see what's happening. And it seems to be working, even though we moved it out to the super unit, but this hero controller is looking a lot more tidy now. And we can also reuse the move unit for other, maybe AI controlled characters or enemies in the future. You can double click on a super unit to jump into it. So we went into the move unit here, and then we see that that flows just as before as well. Let's go back into the main one, the hero controller, right click again and add a new unit. And this time we're going to do get button, because we want to look for a jump key now. So on button input we need for this one. And then we're going to look at the name. It's going to be jump. And again, we can go into edit project settings and go to the input manager. And we know that that one exists there. And in our case, it's the space bar. Then we add another unit. And then this time a float literal again, because we need a multiplier. And then the force that we're going to jump with is 10. We're going to set the velocity of 10 when we jump. This time I right click and I add a nesting unit instead, and we can create a super unit straight away instead, and then click on edit to go into edit that graph. You could also double click on it. Here we can already get those input and output controllers. They're already available there. So I expand just value inputs there and then create a new key there called jump force, and then the type will be a float. And then to the top left, you can click back to the hero in the hierarchy there, and then we have to drag this float input now, the jump force. But we can see that this green arrow doesn't have anywhere to go, so there's nothing to tell the super unit to execute. So I go back into the super unit either by double clicking on it, and then you can click on this control input there, and then we just name this input. You could actually name it anything you want. And then we go back into the hero graph, the hero controller. And now that one will be exposed there. So we can link this on button input event on the green key. We can link to that super unit input. So it actually can execute now. So we go back into the super unit, right click, and then add a new unit. And this time we need to set the velocity of the rigid body. And there's a few things we need to link up to these nodes. So first I'm going to add another component as well, and it's going to be a vector 3. We need to create a vector 3 from X, Y, Z components. We drag the jump force to the Y component, which is up and down in the world. And once the vector has been created, we need to send this green arrow event now to the set velocity, and then we link the vector 3 components together there as well. So we're going to set the force now, the jump force, the velocity of Y, and then we're going to send that to set rigid body. And then we also have to trigger the input using the green arrow connection there. So when we enter the super unit, it's going to create the vector 3, and then it's going to set the velocity on the rigid body. If we press play now again, we can see how it behaves. So I select the graph so we can see what's going on, and then I press space, and we can see that the force is added now, which is pretty good. But we've got a flappy bird effect here, so we can press space in the air multiple times, and we have to fix that. And the gravity is always way too realistic, so it looks even fake. It looks like you're on the moon, but that's real life physics that we're applying there. So we can go into project settings and fix that straight away. We go into the physics and then change the value to -40 on the gravity, and then we can try to press play again. That's looking a lot better anyway. Might have to tweak that a little further, maybe a little bit more of a jump force. But it's starting to feel a little bit more snappy now, like a platformer would do. You don't want to keep that moon lunar gravity setting. Go back into the hero controller and we can increase this multiplier now. Let's put 22 instead of 20. So he's jumping a lot higher now. We're a little bit back, so let's increase the gravity again, -50 maybe. Let's try that. It's a little bit better again. But we have to see how far you need to be able to jump as well. And we don't have any animations yet for the characters. Obviously, it's just sliding left and right. So we're going to fix all those things in just a moment. Still, the Flappy Bird effect is there. Let's make millions. Flappy Hero. Okay, that's enough. Stop it. No, stop it. Okay. Instead of making a fortune on a Flappy Bird clone, let's go back into the super unit, the move unit there, and add another super unit in that one. I just right-clicked add unit and go to nesting super unit. And then we can double click on this one to go straight into it. And then we right-click to add a new unit. And in here, we're going to start checking for the ground. So I'm going to search for overlap box because I know such a thing exists. We're going to pick overlap box center half extents. And then we need to access the position of the player to make this little physics overlap check. So I right click again in the graph somewhere, and then we add another unit. This time, let's search for transform, and that's the name that Unity has for anything that has a position, rotation, and a scale. And then we get position of this transform, and we make sure that's selected to self, and then we link the output of the vector 3 to the center. And then we have to type in the half extents, and I'm just going to put the same as we did for the box collider, 0.3. And if we select the character now, we can see that at the bottom of his feet here now, it's an imaginary box here now of an overlap check. Maybe this is better. I put a little collider at the bottom so you can visualize what it looks like. It's just an invisible little box there to be able to see if there are any physics overlapping colliders there. Let's go back in the graph and expand this value outputs, and we'll enter a new key here called IsGrounded, and the type of this one is going to be a boolean, so it's either going to be true or false. But we can't link this output because that's a list of the number of colliders, or it's a list of colliders that is currently overlapping. So I right click to add a new unit, and we're going to search for count items here, which is a built-in component here that we can use. We'll link the output list to the input list counter there. And then the blue value there is going to be a value and an integer value, and we can count that. So let's add a greater than check, and then drag the output, the blue output, to the blue input. And then we make sure that this is going to be greater than 2. And the reason why I put 2 there is because if we remember the hero here, he's got a box collider and a sphere collider, so it's always going to be overlapping 2 colliders there. So if we're checking for a greater number than 2, it means that it's also touching something else, and that has to be either an enemy, or in our case, it's going to be the tiles that he's standing on. So we have to check if it's greater than 2, and that outputs a boolean, or a true or a false value, and we'll link that one to IsGrounded output. And now we've created a little super unit here that checks at the feet of the player if it's connecting with the ground. But there's one more thing we have to do. It won't run by itself, so we have to add the fixed update event, which is running every physics update here, and we link this little execution green arrow to make sure that the overlap check is run at all the time. We don't have any inputs, so we can delete that one. Okay, let's go back to the top here, the hero controller, and we can double click into the super unit here that we have for the jumping. Now we have this IsGrounded output, and then we can do a branch, which is an if statement. And then we link the little pink purple output to the input of IsGrounded, check if that's true or false. And then we have to make sure that the input here first goes through this branch or the if statement, and then continues to create the vector 3 to set the velocity. And it should only do that if it is true. And then I can never figure out how to get this tidy, so I move it around. Usually it doesn't get any better, but I try to make sure there's not too many overlaps. Okay, now let's press play and check this out. We can see that the fixed update is running, but it's not really sending any output because no one's listening for it. But when we press space, it's counting the items and it's returning it out. And it's only firing this because it only enters that one when we send the input there, or the jump button. And then we can see that we can't really press space in the air again, so the Flappy clone is now history. You can also type a little input here. I named it IsGrounded and then put a little description to it. You should probably do that to keep it tidy. In the hero controller now, since we created the super unit inside the graph, it's actually part embedded into the graph. So if I click on convert there, we can actually give it an asset name, and I just type it jump, and that saves it as a reusable graph instead that other objects could use. You could reuse this little graph for enemies or other player types. And then it just gets the IsGrounded super unit input, and then it takes the input from whatever you send in, the jump force, and then it creates a vector 3 and then it sets the velocity of the rigid body. And we've now got a pretty decent jumping mechanic here that doesn't allow you to jump in the air. And we could also tweak the values a little bit more. If you don't want it to jump less, you just type in a little lower value for the multiplier of the force, or you could also just increase the gravity a little bit extra as well. We left a little dangerous thing going on here, and we have to add another get velocity from the rigid body here. And then we have to get the X component and link that up to the X component. So we maintain that one. The only reason why it probably worked now is because we don't really know which order these run, the different flowcharts, and the ones that sets the X component probably ran before or after this one. So it probably overwrote the value that we set here. But it's important that we make sure that it carries with us the X value as well. So we don't just set the Y and then leave the Z, or force the X value to 0. For the Z direction, we can leave that as 0 because we never want the character to go into the mountains or towards the camera. We'll go back to the hero controller, right click to create a new super unit, double click on that one. And then we're going to name this one face forward because it's time for our character to turn. So we add a value input called horizontal again. That's going to be a float. And then we right click to add a new unit. And this type, we create a vector 3 XYZ component once again that we've done before as well. We link the horizontal to the X-axis because we want the character to be facing in the world X direction. We add another unit, and this type we're going to do transform set forward because we want to set which way should be forward in the world for the player. We link the output of the vector 3 to the input of the set forward direction. And then we also have to ensure that we link these execution arrows up. I'm not sure what they're called actually. But we want this to run in the update loop. So every update, the green arrow connects to the create vector 3, and then we send that to the set forward. We also have to link the horizontal input now into this input of the face forward super unit. And if we press play now, he's facing in the wrong direction. And that's an easy fix. Sometimes it's easier to test than to think. So if we go back into the unit there, we just add a multiplier, and then we link the horizontal there, multiply it by -1, and this way we've flipped the X-axis now. So if we press play again, now it's facing the right way. He's still sliding, but at least he's facing in the correct direction. Okay, this one won't have any output, so we can just delete that one. We don't need it. And then we go back to the hero controller, and this is also another reusable component, so we'll convert that one from embedded and then put it in the same folder as before and name it face forward. So we can reuse this super unit for other characters now. So far we've got a few graphs here now, and they're neatly packaged into little solid containers. Right, we're going to stop sliding the player now, so let's right click on the bolt folder here, create a new bolt flow macro and name this one move animation. We need an input there, so for the key we need to get that horizontal input again, and then the value is going to be a float, so that's going to expose that value input, and we need to go to the nesting and then show that input as well. And then we add another component here, and we have to do the animator set float, and then we link the horizontal input to a value, and we're going to name this parameter for the animator. It's going to be named speed. Then I have to go to the animation controller, and then we can see that it's currently only got the T-post there. But I have to go, first I move the animator just up and link it so I can see the game world. If we press play now, we can see that it's just got the T-post enabled at all time, as we knew already. So this one we have to change. We can go into the meshes and see what we've got here instead. So for the hero, it's got a run animation. I can just click and drag that one into the animator window here. And then we have to make some transitions here. So I right click from the idle state, make transition to the run state. And in order to transition to this state, we need some input here. I have to go to the parameters tab here and name a parameter. And we named it speed, the one that we're setting from the flow graph. So I'm going to name this one speed as well in the animator. And now we've got something to transition on. So we go back and make sure the arrow is selected there. And then click to add a condition, and then if speed is greater than 0, we want to make this transition. And we have to transition back, so I right click on the run one and then make transition to idle. We add the condition here, and then we're going to put, okay, so we can't really put we can't put less than 0. So we have to put speed if it's less than 0.01, and then we change the transition to that one if it's greater than 0.01. There's no such thing as an equal, especially not for floats. Okay, still nothing is happening, so we have to figure out why that is. So if we look at the flow graph here for the main character controller or the hero controller, we have to drag the move animation here, super unit, into the controller and then link the horizontal input to the horizontal input. And it still won't really run because as you can see, it's grayed out, and we have to add a little event for this to happen. So we add update loop. So every update loop, this is going to be firing off the set float for the animator. Now we can see that it's running. So if we press left and right, he's starting to run. At least he ran in one direction, but not the other. So it's a step in the right direction. Multiple steps in the right direction. For him to run the other way, we have to right click and do another transition to the run animation, and that creates a new transition up there. If we select that one, we have to make sure that it's a new condition here. It's going to be if speed is less than negative 0.01. And for the transition to go back to idle, then we have to add another condition on the same transition. So it's going to be if speed is greater than negative 0.01 or if it's less than 0.01. And now if we press play again, and then see he runs right and he runs left. And he jumps, but he runs in the air. Another thing to fix. You'll find that as you make stuff like this, when you solve one thing, you'll have something else to deal with. But at least he's running now. It feels pretty responsive as well. There are a few things that we can do to tweak the responsiveness even further to reduce the lag of the input, for example, but we'll have a look at those a little bit later on. Now we should really change this idle animation. We can't have him running around in a T-pose, and we've got a problem there because I forgot to model or I forgot to animate an idle position. So I'm just going to fast forward this part because it's not part of this particular video. But I jumped into Blender and I just animated a quick idle animation for him. And then I had to export that one. And it's a problem. You can't really overwrite the FBX file once you export it again. That creates a lot of problems. Unity doesn't really like to import it. It corrupts all the animations. So what I ended up doing, I had to go back into Blender once again. And then I had to export that one animation alone as an NLA track. And I'm going to be creating some videos on this in the future. And I also have quite a few videos in my tenement modeling challenge if you want to learn how to keyframe animate. But I'm going to do some dedicated tutorials on that as well. But in the end here, I got the new idle animation imported as a separate file. And then we can drag this one in now. It's running here in the editor. So I just drag the new animation in to the animator. Replace the previous T-pose here with the new idle animation. And now we can stand here. As he pauses to run, he stands still and taps his feet a little bit. We've still got the running in the air issue, which we can fix in a little bit. But what I wanted to do first is, as he turns around, he has a tendency to do a little slide. And maybe that's something that you want, but let's make that a little bit more responsive, as I mentioned earlier. If we go into the transition here of the animator, we can expand the settings, and then I change the transition state here to 0.05 instead. So it's going to be 50 milliseconds. So as he transitions into the run state and you turn around, he doesn't really do that slide anymore. Okay, let's fix this running in the air issue. If I have the hero selected here, I go to add component, and then we go to bolt, and then add a flow machine here. This is another way you can do it. You can actually have many flow machines on the same object. We've put most of the things in the hero controller now, but we're adding another one now. And here you can click on new for the macro, and here's another way then to create a new macro or a super unit that could be reused. And let's call this one fall animation. And we click to highlight it and then just go into edit graph. I think I'm actually going to rename this to jump fall animation because we're going to create a blend tree that blends between a jump pose and a fall pose. If I go into the graph editor and the graph inspector here, let's name it neatly jump fall animation. And then we can add a new component here, and then let's do the fixed update, and we don't really need the other events here. Then we add a new unit here, and this time we want to set the float of the animator, and we're going to set the name and the value. We link the event here, the fixed update, to run this set float. And then we want to set something called vertical speed. And then we have to set something here as well. So we add another unit and we get the velocity of the rigid body. And then we link this one. First of all, we need to grab the Y component, which is up and down. It's a vector 3. So we get the Y component and drag that to the float value here. So that's going to set the vertical speed of the animator. And we can also take the opportunity to add another one here as well. Let's add set bool. And animator, we want to set the bool. The name of this one is going to be IsGrounded. We haven't created these yet in the animator. We'll do that in a minute. And then we link the execution thing together, very important, so it actually comes to this stage. So it goes in the fixed update to the set floats and then the set bool. We add the nesting component here and we have to grab that super unit that we had before. And this one is going to be the, if you remember, we created one called IsGrounded. So we switch this one to a macro instead. And then we pick the IsGrounded macro. And then we drag this little bool one into the set bool of the animator. So now we've set the vertical speed and we've also set the IsGrounded to true or false. Now we can, in the animator again for the hero, we'll expand it to give ourselves a little bit more room here. We can rearrange these windows as you see fit as well if you need more space. So I'll just want a little bit more space here in the base layer. And then we add a new parameter. This one is going to be called IsGrounded. It's a true or false bool. Then we add the float, and that one was called a vertical speed. Then we have to right click and create a new state, and it's going to be from a new blend tree. And you can double click on this one to go into it, but first let's name it Jump Fall Blend Tree. And then we should make a transition as well, and you'll be able to transition into the jump and fall pose from any point. So we're not going to link it from the idle. Let's move it over here so we can actually send it from any state now. Right click on any state, make transition to the jump fall blend tree. And the condition here is going to be if IsGrounded is false, then we're going to go into this blend tree. And if we'll make a new transition here as well to idle. So the condition here is going to be if IsGrounded is true. Now double click on the blend tree to go into it, and then we have to add some motions here. We'll add the motion field, and we're going to have to add 2 here because we want to have one jump pose and one fall pose. And then I can grab the jump pose here, and then we'll pick the fall pose as well. And that will blend between those. The default values is 0 and 1 here. And usually you have to tweak those a little bit. And we can set the parameter to vertical speed. That's going to be dictating what's going to be happening. So if we go to press play now, we can see that he's no longer going to be running in the air. And he's lagging a little bit, and it's got a little weird behavior there. So something's wrong with the transitions and the blend tree. We can look at the blend tree as we're jumping, and we have to make some changes here. So first is to reverse the poses. I got them wrong. So let's just drag and flip those directions there and see if that looks any better. Yep, now he punches up in the air and then he tries to fall down, but it's still not very smooth. So then maybe the values here we have to change. So it's probably the speed values here. So we have to switch off auto thresholds and then type -1 and then +1 for the jump pose. And we'll try it again. Okay, all right, it's not so good still. So let's go back into the transition. First of all, we have to make sure it doesn't have any exit time, and it does. So we have to disable that one because it needs to be able to transition straight away. And the duration we have to change as well to 0.05 here again. So 50 milliseconds, both in and out of the blend tree. Okay, let's try one more time. Okay, it's looking better. He's more responsive now. He punches in the air as he jumps up and he falls down. But we can probably change those values still a bit because they're not so close to 1 and -1. So let's change them to -10 for maximum pose and 10. That should smooth it out a little bit more as he accelerates up and down through the air. Yeah, that looks a lot better. So now we've got him, the camera's not following, but at least he's running now. He's got the animation going, he's jumping pretty decently, and his arm go up as he falls down. We can go into the project settings now as well, and let's bump the gravity up a little bit further even. Let's try 80. Okay, pretty cool as well, but I think that might be a little bit too much gravity, so let's just switch it back to 60, somewhere in between there. So -60 we'll put there. Okay, that's good enough. Let's leave it at that, and you can play around with the gravity as you want as well. Oh, and we've got this issue now where it gets stuck on the wall if you move sideways, so we're gonna fix that one now. And for this we need to create a physics material. So we've got a folder here called physics material. If you don't have one, can you just create one? Right click and do create a new physics material. We'll create this one and name it no friction. We'll set both the combined values here to minimum, and then just set the friction, both the dynamic and static, down to 0. And then we have to actually map this to the colliders of our hero now. So if I access the hero here, we can have the two colliders. We just drag the no friction material onto those two material properties here for those colliders. So now with 0 friction, even if you jump into the side of a tile, he'll just slide off it right down. Problem fixed. If you want the character to even be more responsive than it is when you turn left and right, you can go back into project settings and go to input, and then go to the horizontal axis, and then up gravity and sensitivity to about 100. It's a little bit laggy by default because it interpolates up and down to max value, and if you change that one to about 100 or more, then you'll have really rapid controls there. So maybe it's too fast, maybe it's somewhere in between that you want. Just play around with those figures. Now we should add some jump sounds as well. I'll create a new folder here in the assets folder, and then let's just call that one audio. And you should check out my sound library, Universal Sound Effects. I'm just going to drag a few of the sound effects from there right into here. I sell that for about $40, so you should pick that up if you want. It's pretty useful. It's got thousands and thousands of useful sound effects for any type of games that you might want to create. This is just a small subset of all the sounds. Anyway, we'll go back into the jump one here, into the flow graph. Then we'll pick a sound here, and I added a audio source, play clip at point. And then we pick any jump sound here, and have the execution just set it to execute after it's set the velocity here. And then we have to add another unit here as well. We have to set the position right. So I'll get the position from the transform, and we'll make sure that self is selected there, and then get the vector 3 position, and set the volume to 1 as well. Also important, it's 0 by default. Not so good. If we press play now, we'll have a little jump sound as he jumps around. So that's how simple it is to add the sound effects. And remember, Universal Sound Effects. Go grab it. Link is in the description. We added this jump fall animation flow machine as a separate object, or a separate component to the object, and it doesn't really have to be the case. So what we could do is just get rid of it here and move it into the hero controller here. So if I just drag it in, the jump and fall animator, then we can remove the component from the game object itself, so it only has that one flow machine that controls everything. But the jump fall animator is still reusable for other objects. And it still runs even though it's not linked up, because it's running from the fixed update here. So we can see that it's actually operating if we go into it. Let's just have a look at the different ones. So here are the different flow graphs. You can see that they're all up and running. They're running either through the update loops or through event inputs from, for example, the left and right and the jump button here. And the final one as well, this jump flowchart. And it's really nice to have them like reusable like this, because if you bundle everything into one big flowchart, it's not going to be able to reuse it, and it's really difficult to see what's going on. Now we've got a problem here as well. I've encountered this one before. If we raise this character up and drop him right between two blocks, so you can see that he falls straight through. And that's a problem with the physics engine when we're having such high gravity. There are a few settings that you can tweak, but I've actually not been able to configure the physics engine, the iterations or solvers high enough to prevent that. So the best solution I've found is what we'll do is create a new flow machine here as well. click on new and create a new asset here, and let's call it limit fall speed. If we go into this one, we can delete these two and add the fixed update event. And then right click to add a unit, and then we set velocity. And then we have to add another unit here, and this one is going to be get velocity, because we have to get the rigid body's own velocity first of all. We right click again and search for get x and get the vector 3x from the velocity, and then we link those two together. And we have to add another unit, and this time we're going to create a vector 3 xyz, and then we'll get the x component there, feed it into the new vector 3, and then z can be 0. We have to make sure that we link these up as well, set velocity and setting the actual vector 3. And now we have to get the y component, and we're going to get that from the velocity as well. But we have to limit the y component now, the y speed. This is the whole purpose of this, to try to limit it. So we have to add another component, and this time around, let's put the maximum component here. Move these a little bit to get some space, and then we'll link the get y there into the a value. And then we add another float literal this time that we can type in manually. And then we'll set the limit to maybe -30, and then link that to the b. So it's going to pick whichever value is highest. And remember, if it's -60, then -30 is the higher value. We can change the fixed update here. It can either go straight into the vector 3, but as you can see now, we can actually, you get this little glitch as well. Sometimes you have to click into that field and escape out of it if you get that graphical glitch, so you know. But you can get the fixed update to run straight to the set velocity, and it'll actually pull the values from that vector 3. But the player still fell through, even though we put this little safeguard in place, so we should probably limit the speed even more. Let's stop this one and change it to -15, and then we press play to try this one again. And this time he falls down and lands without falling through. But maybe we limited it a little bit too much. He felt like he was falling down a little bit slow, so let's bump it up a little again, and to -20 will be our new limit then. That looks pretty good. So he's still affected fast by gravity up and down, and it limits the fall speed so it doesn't go ultrasonic on his way down, catch fire in the atmosphere. Or more importantly, it doesn't go through the tiles. Okay, we can move the camera into the hero, but as you can see, that doesn't work very well. And it's because we're facing the player character in the direction he's running. So we're gonna have to find a different solution, and we'll create another flow machine here on the camera itself instead, as it's not parented. Let's name this one camera follow. And let's add the late update. Camera updates you want to do in the late update loop, not in the normal update loop, because it needs to do that after things have been rendered. So we search for set position of the transform here, and that's going to change the camera's position. We have to add a unit here, and we're going to get a variable this time, and it's going to be an object variable. So get object variable. And now we have to go to the variable tab on the right in the inspector for the actual object itself. We create a new variable there called target, and then set the type of that one to a transform. We have to browse our way. Either we could search it, but I want to show you how to browse as well. And it takes a long time to find your way sometimes, so usually searching is the better option here. But again, transform is Unity's way to inform if something's got a position, rotation, and a scale. So we have to make sure that we got that one, and we set the hero to the value of the target because we want the camera to follow that one. And now the get variable on the object there is available for the dropdown, and we can drag and link that one to the position. And you can see that it's actually grayed out here, and it's because the late update needs to execute to the execution there as well. We've got a red light coming on here, and it's not really working. It's throwing an error here as well. And it's because you can't put the transform straight into a vector 3. So we need to add another component here called get transform position, or get position. And then we get the variables position and then feed that one into the set position instead. A little bit better, but the camera is now right on top of the object itself. So we need to create a little bit of an offset here for this to work. Otherwise, the camera is going to be on his shoulder pretty much, or inside of his body. So we add another component here, and we have to do a set flow variable. And we're going to set a variable that we can call offset here. And then we link the start event to set this variable. And then we can copy this get position one here because we need to get to another position. And this time it's going to be self. And then we subtract here self. We have to get, so self subtract the position of the target transform, which is the guy that we're following, the hero. And then we feed that one to set the flow variable, which is called offset here. And that's just to get the initial distance between the camera and the player as we press play. And then it's time to position the camera properly here. So we add the variable, the flow offset, to the current position of the camera. And then we set the position to this new value. So we're basically, all of this was just to get the offset from the camera to the character, and then offset that camera every frame here. We get an error here as well, and that's because we can't drag it from that variable. So I get the variable instead, and we get the offset variable and use it that way instead. And we've still got an error here, and it's because I've actually set flow variables here. And I need to switch those to graph variables, which is actually local variables or private ones for this particular graph. So if we press play now, then we should have the camera following at a bit of a distance now instead, according to that offset. I would recommend learning to use Cinemachine because that's really good to get really nice camera work in Unity. But for now, let's manually add some lag to this, or some dampening effect. We can do this by adding a vector3 lerp into this graph. So vector3 lerp, and then we have to rearrange things and make space for it. And lerp is a linear interpolation between two values. So we get the camera's own position now, and then we lerp from that one to the new offset position that we want. And then we have to set the t value, or the time value, for the lerp as well. And that's between 0 and 1, and 0 is back at A, and 1 equals to the position, the B position. So any value in there between is the linear interpolation between A and B. But for this, we're actually going to use the get delta time here, because this is frame dependent. So depending on how fast your game is running, it's going to run at different speeds. So we can lerp just, that's usually a small value, 0.01 or something like that. So it just slightly lerps towards the new location from its current location. And that is a pretty easy way to get a dampening effect to the camera movement. So let's try it out. Okay, that's a little bit too laggy, so we're going to have to introduce a little multiplier here as well. Let's add another one. Let's do a multiply, and then we feed the delta time into there, and then we just multiply delta by 3. Let's try that. You can hold Control and drag to create these little frames as well, and you can name those. So let's just call this one smooth movement, and then you can actually move the whole group then that way. Pretty handy. It's a little bit buggy though, I'd say, the implementation. It's a bit difficult to get them to move properly or resize them. All right, let's try that one more time. And if we run left and right now, we should have pretty decent camera dampening movement. And again, I'll probably do a video. If you subscribe, you should check out a video in the future that I do on Cinemachine, because that's a really good way to get this out of the box with a lot more cooler features as well. Okay, we've got one more thing to fix. We see that there's an error here. It's a look rotation problem here. Viewing vector is 0, and it's because when we're doing this face direction, it's sometimes when x is 0, then the entire vector 3 there will be 0, and that creates an exception or a problem that it can't handle. So we'll have to do, let's do absolute value of the horizontal input here, because we need to compensate that when x is closer to 0, then z has to go towards 1. So we'll subtract here. We'll take the absolute value, which is going to be 0 to 1, and then we subtract 1. And then we also have to add another unit here. Let's do multiply, and then we multiply this one by -1, because we need to flip it as well. So feed that into z, and this is just to get rid of that error, because it can't have a 0 vector. And now suddenly when x goes to 0, then the z direction will point the character towards the camera instead of leaving it at 0. So this is as far as we've taken this whole bolt implementation now. We've got pretty much all the features implemented. So what do you say we do the same thing in C# now? So you might be surprised. Do you think it's easier or harder? I'd created a scripts folder before, so go there or create one and then just create a new script called Hero Controller. And that's going to be a C# script. Then we can click on our hero and we have to disable the flow machine now because we don't want that one to do anything at all. And then if I press play now, you see nothing is happening. We're back to square one now. Back to nothing. So we double click on the hero controller and that brings us into edit this script. So we want to add that fixed update loop. That's a method that Unity runs every fixed update. And the first thing we're going to do is implement the move logic. So we do input get axis horizontal. That's the same as we did in the visual script pretty much. But we'll map that to a float, a temporary variable. Now we need to do something to the rigid body. And the way you get that through the C# script is we'll create a private rigid body variable up here as well. We have to declare that at the top. And in the start method that runs when the game starts or when the game object is created pretty much. Then we do rigid body equals get component rigid body in brackets there. And then in the fixed update now we can do rigid body dot velocity equals. And then to specify a vector 3 you have to create a new one. So new vector 3. And then we do horizontal for the x component, comma, and then we have to grab the rigid body's current y velocity. So we do rigid body.velocity.y, and then we force the z component to 0. We don't want it to go in or out. And that's it. We've implemented the entire visual script of the move logic now. So we have to just drag this hero controller script onto our hero and press play. We'll try it out. And yeah, we're back to square 2, where we were. Basically, is moving left and right now without the speed multiplier. So I lied a little bit there because the entire script wasn't quite implemented, but it's not far off actually. So let's address that one. We declare a new private variable. This one's going to be a float called speed multiplier, and we set that one to 8, just as we did in the visual script. And then we multiply horizontal for the x component there to the speed multiplier. And now we're back to square 3. So he's going left and right at the normal pace that we're expecting. Okay, now we're going to implement the jump graph. So we declare another variable at the top, and it's going to be a boolean called jump. And we have to grab this one in the update loop. It's very important to do it up here instead of the fixed update. We grab the input get button down, and it's the jump button that we want. And then we store that in the boolean variable here, jump equals true. The reason why you can do horizontal input in the fixed update is because that's a value that's set constantly. But the fixed update is called once per physic update, which is usually 100 times per second in Unity if you haven't changed it. But the get button has to be done in update because the fixed update loop can miss that input. So very important. All right, now we do if jump. Then we're going to set the rigid body velocity. Again, we have to create a new vector 3. That's how you do it. And then for the x direction, we have to grab the rigid body's current x velocity, comma. And then here we type 22, which was the value that we set last time for our y velocity. And then comma 0, we force, again, z to 0 here. And instead of actually typing that one in as 22 in the code, let's declare a variable here called jump force and set it to 22 up here instead. And then move it up. And then just replace this 22 here down here by jump force instead. Keep the variables at the top there. So this is the jump logic implemented now. But we also have to set jump to false again, so it doesn't keep jumping forever. So now we've implemented the jump graph as well in a C# script. And we're back to flappy clone here. So I stopped it earlier this time. Pretty good. All right, on to the next thing. We're going to implement the IsGrounded graph now. So I'll type a little comment here so we know. As you can see, I'm putting everything here into the hero controller script. It's no real need to split it out into separate objects because it's not as spaghetti-like as the graphs are. So here we do if physics.overlap box rigid body position. And then we have to create a new vector 3 here, and we want to have it 0.3.0.3.0.3 in the size, same as we did in the visual script here. And then I was tempted to write count here, but you shouldn't really type count because it's not really a collection that you can count. it's an array, so we have to replace that with by length, if length is greater than 2. And you can also replace this, maybe you want to type it vector 3.1 times 0.3f, a little bit easier to read and quicker to type as well. So we have to do something now as well. So we declare another variable. It's going to be a bool, IsGrounded. And now we can set that one here. So if that count is over 2, same as the visual graph did, then IsGrounded equals true. So now we've implemented most of that logic. And if it's not true, then we have to set it back to false. And here we can actually type this whole thing a little bit easier and save us a lot of lines of code here. So if instead we just copy the physics overlap box here, we set IsGrounded equals to, and then that statement, because that's going to be either true or false. Now IsGrounded is going to be true or false just on that one line instead of using the if statement. All right, and we also have to check now when we jump. We have to if jump, if cached there from key pressing it, and IsGrounded, then we're allowed to jump, not otherwise. So otherwise you could still do the flappy clone here. And now, yep, you can jump in the air, but you can't jump in the air. You could jump when you land. Now we're going to go on to face forward, and I have to rearrange a little bit here. So first of all, we need to reuse this horizontal input one. So let's move that one up into update, because we want to grab it up here instead. We need to use it up here. Let's press F2 to rename it to horizontal input, and then put a little comment here again about the capture jump button has to be done in update. And then we store the horizontal input here so we can use it in the fixed update as well. So now it's time to do the face forward graph. So we do, in the update loop here, we do transfer.forward equals new vector 3. And then here we type in horizontal input, it's the X component. And then for the Y component, we have to do 0 and then 0. And as the graph said as well, we actually have to do negative horizontal input, because otherwise it'll face the wrong direction. We press play, that part worked. But we are getting the look rotation error here as well, and that's because we didn't actually implement that part. So for the Z component, we do mathf.abs for absolute, horizontal input, -1. And then this in brackets as well, because we have to actually do this in negative as well, because otherwise it'll face away from the camera. All right, now it's facing in the right direction, and we don't get the look rotation error there, so doing pretty good so far. Now let's get the character up and running again. So up in the start method, we have to do _animator equals get component animator. And then you can, instead of declaring that, you can press Control period and press enter, and that will actually create the private animator variable at the top. So down here now, we do in the update loop _animator.setFloat, and then it's going to be the speed variable, and then comma horizontal input. And now it's still not running, and there's a good reason for that. It's because we've got the IsGrounded issue. So we have to set the animator IsGrounded as well. We do _animator.setBool IsGrounded with a capital I, we named that one, comma IsGrounded, which is the local variable here, or the private variable in this script. And now when we press play again, then we'll have the animation back up and running as well, just like we did with the visual script. All right, time to get the jump fall animation in as well. So we go down into fixed update, and here's where we'll be setting the animator again for the, it's going to be the parameter for the jump fall animation. And if you remember, we created a variable called vertical speed. So we do animator.setFloat, and then in quotation marks, vertical speed, and then we set that one to the rigid body's velocity.y component. That's it. It should be fixed now. So the animator will now get fed in with that vertical speed value, or the velocity, and the blend tree takes over from there in the animator component. With this implementation, we actually have to look if IsGrounded is set when we do the jump button. Otherwise, it'll cache a jump button when you're in the air and jump when you land. So we check if the jump button is pressed, and also if it is grounded, only then will it jump. That fixed that problem as well. We didn't really have that issue the way we implemented it in the visual graph, but in the script it cached the jump all the time. If you recall, we also had to limit the fall speed so we didn't fall between tiles when we had a high velocity if you had jumped from far above. So we do that in the same script here in the fixed update, and we do rigid body dot velocity equals a new vector 3, and it's going to be the rigid body's x velocity here for the x component, but for y we're going to have to do mathf dot max value, and for the first value here we type in negative minus 20, which is where we want to cap it, comma rigid body dot velocity dot y, comma 0. But we should actually really do, for common practice here, it should be rigid body dot velocity dot z, but we happen to want to limit that one to 0 most of the time in this game. So now we've implemented it so that it can never fall lower than negative 20, so we've protected ourselves against that bug where it slides between tiles. Okay, it wouldn't be complete unless we actually implemented the camera movement as well. So we'll create a new C# script for that one called camera follow. And for this one, we have to declare a new, I usually put public transform here, target, but we'll change that one to private for common practice. And it's going to be a serialized field, so it shows up in the inspector. And then we set it to null so we don't get a warning there as well, since we're serializing the private field here. And then we also need to do a declaration of the vector 3 offset here. And then in start, in the start method, we do offset equals transform.position minus target.position. So we take the camera's position minus the target's position, as it is when you start the game. And then we have to use this in late update, because camera updates should be done in late update once the camera has finished rendering stuff. Here we do transform.position equals vector3.lerp for linear interpolation. And we lerp it from the transferred position, from the current position to the target position plus offset. And then we the time variable is going to be time.delta time times 3, just like we did in the visual graph. And now we've implemented the dampened movement of the camera as well. First, we actually need to assign that script though to the hero itself, or to the camera, of course. So, and then we have to assign the hero now to the transform, and now the camera script is behaving in the same way. We disable the flow machine as well to make sure it's the script that's running this as well. Sounds a little bit silent, if you now can hear that something is silent, so we have to reinstate the sound. So in the hero controller, we declare a new serialized field, private variable here, and it's going to be an audio clip. And let's call that one jump sound effect. And we have to set it to null as well to avoid that extra warning that usually comes up if you don't do that. Now we scroll down here to the fixed update, and in the little if statement here where we actually do the jump, then we do if jump sound effect is not null, so if we actually have defined it, then we can do audio source dot play clip at point, and then we have to get the jump sound effect clip there, comma, and then we get the transform's current position, and then we can actually add the volume as well, comma, and let's put it at 0.5. Can't remember what we put it last time. And now we've got the sound back. We linked the sound effect up to that exposed variable as well there. I also mentioned something that you shouldn't do, and I don't recommend you to implement the visual graph like this. This is all the scripts implemented into one big graph here, and it makes it extremely confusing to see what's going on, and you can't really reuse any of it. So I really recommend that you do the approach that we went through this whole thing. Try to break out everything into little components that you can reuse, because you'll have enemies and other players and other objects that you can reuse all the logic if you keep it neat and tidy like that. All right, everyone, are you still with me? I hope you managed to pull through this. I was going to try to keep it under the hour, but I just went a little bit past it. It wouldn't be like me if I didn't go over time. But I hope you found this useful. I wanted to show you both how to use Bolt, and at least just the very basics of it, at least to get something in place. And I also wanted to show you that it takes quite a lot of time and effort to create these little graphs here. And compared to the scripting as you saw in the end, now I've done a lot more scripting than I've done visual scripting, but I find that typing in the scripts are a lot faster to do than actually doing the visual graphs. So have a good think of which way you want to go forward. I'd say that one of the big benefits of using the visual graphs is that it forces you to simplify everything into the core logic exactly the way you want it, and it also helps you to compartmentalize the different logic into separate reusable objects. So that's a very, very good upside of using it. And you also get a good oversight of what's happening. But I found debugging it a little bit more difficult compared to code, because if it throws an error in the code, you just double click on the error and you get to the code and you go, okay, I'll fix it. So I found the debugging of the visual scripts, of the bolt script, to be a little bit more complicated. So maybe a combination of the two could be good, or maybe you should focus on the visual scripting if that's what you want to do, or maybe you should focus on C# if you realize that what you're actually doing in Bolt is you're doing programming logic, you're just doing it visually instead of typing in the commands. So maybe if you do visual scripting, you'll actually learn programming without even thinking about it. So maybe that's a good upside, and I think you should try a little bit of both and see what fits you the best. If you like this video, please consider giving it a like and subscribe if you haven't already. And I've also got a Patreon page if you want to check that one out. It's patreon.com/Imphenzia, and I upload my tutorial stuff. I'll put this one up there as well. So if you're a patron in the tutorial tier, then you're going to be able to download this project file as well and have a play with it, and you'll get all the visual graphs since Bolt is now included in Unity anyway. And also check out that universal sound effects pack that I sell on Imphenzia.com. The links to everything is going to be in the description, so go there as well. And until my next video, I hope you have a great day, and I'll see you then. Bye for now.